So let's get into our next session. Our speakers are joining us from Synkrato and their client Zebra. Synkrato is a powerful, intelligent AI platform that leverages advanced algorithms to optimize logistics and warehouse operations. It uses data analytics and machine learning to enhance decision-making and operational efficiency. With the Synkrato platform, you'll gain access to a digital twin of your physical warehouse, where artificial intelligence will reshape your decision-making processes within the warehouse and enable you to rapidly scale your operations. Amin is Synkrato's supply chain and logistics expert. In the early days of his career, he was one of the original architects of Oracle WMS. He also co-founded Gaia and developed the label management platform Cloud Label Service, which is now the digital labeling component of Synkrato. Abhishek will be joining him and is the seasoned IT supply chain technology transformation and growth leader with 18+ years of experience driving global implementations in distribution centers, supply chain, and manufacturing applications. So we've got a stacked presentation. Please welcome to the stage with a warm round of applause. We've got Amin Sikander from Synkrato and Abhishek Mishra from Zebra.
Thank you. Hello, good morning, everyone. My name is Abhishek Mishra, and I'm Senior Manager in IT in Zebra Technologies, and I manage all the applications in distribution centers and repair depots and manufacturing plants within Zebra. So I have an honor of presenting this, co-presenting this with Amin Sikander, who is the CEO and co-founder of Synkrato. And I want to go over the road to the autonomous warehouse that Zebra has started. There are multiple initiatives that Zebra has been doing on this, and this is one of the most critical one that we just started with. So I want you all to imagine that you have a twin, and that twin knows exactly what you're doing, when you're doing, and how it's done. And it works tirelessly to optimize your next move, and it knows this is how it needs to be done, and we have the next move. It could be anything in your warehouse, right? So this is the digital twin that we are going to talk about is the reality that we are working in Zebra Technologies, and that reality is not of science fiction. We are trying to convert that from fantasy into fact with the help of the digital twins of the warehouse. So let's dive into this journey, and here's the agenda for this deck. So we are going to talk about Zebra, a little bit about Synkrato, what are the supply chain challenges, like AI hype and reality. And then we are also going to talk about how Zebra and Synkrato came together on this initiative. What is the problem statement? What is the solution? And what's next, right? What was the roadmap for the future? All right, so Zebra is an organization which takes care of all the asset visibility and tracking for our customers. So we have products and solutions that are in that area. We are #1 in mobile computing, data capture, barcode printing, and mobile RFID devices. And we also enjoy the leader status in Gartner Magic Quadrant. And we have 50 years of commitment towards the innovation. So we were founded in 1969, and one of the critical acquisition that we have done was Motorola acquisition when we acquired Motorola Enterprise Solution, and on the day of closing, we tripled our size. So that was one of the things. And then we are also the official partner for the next gen stat for NFL. So all the NFL, the chips that go on the shoulder pad of the players, And those chips can track their acceleration speed and the movement of the players. So that is shown on the TV when you're watching NFL games. And then we have done a lot of investment organically and inorganically into the business. We have grown, and we have done a lot of innovation all along the whole journey of Zebra. And last 4 years, we have done like 9 acquisitions. We are doing a lot of machine vision and Zebra robotics and autonomous warehouse. So about Zebra, we are like $4.5 billion company. And on this slide, I wanted to focus on the R&D investment. We do like $500 million of R&D investment. So this shows our commitment to the innovation. All right, Amin, you want to?
Right. Thank you, Abhishek.
Yeah, thank you.
And first of all, thank you all for taking the time to be at the presentation, and thank you to Generis for giving us the opportunity to speak today. A little bit about a background about myself. I describe myself as a warehouse geek, because that's how I think of myself. I've either been implementing or building WMS solutions all my life. I ran a services company that helped our customers implement WMS solutions all across the world, right? So we have seen a lot of these challenges upfront and personal, right? Our mission with founding Synkrato was twofold, right? One was we were tired of fixing the same problems over and over again at our clients, right? And furthermore, the current technology allowed us to solve problems that we really couldn't do so before. And we're not trying to solve the world's problems, right? We just want to solve the problems within a warehouse. That's our goal. All right, so talking about the specific problems we're trying to address. When we took a step back and looked at some of the challenges that our customers were facing, right? First one is obviously labor. Everybody's dealing with labor shortages. Labor's productivity has been pretty stagnant for the last 20 years. More crucially, labor availability is becoming more and more of a challenge, and that's a problem that's not going to go away. Gartner predicts that labor will probably end up being the single biggest operational constraint for most warehouses. So that's a huge challenge that we have to deal with. Second is changing customer expectations, right? I don't know about you folks, but when my wife orders something online, it better be here either today or tomorrow or in 2 days, right? Otherwise, she's going elsewhere. And that shift, precipitated by Amazon, but now followed by pretty much everybody, that's led to a more complex and fragmented supply chain. There's been a proliferation of warehouses around the country because at the end of the day, you have to have your product close to your customer. And that's led to a larger number of orders, smaller orders, but the number of orders is more, which is fundamentally far more complex to pick than picking big pallets of stuff and shipping it out, right? Now, most people anticipate that emerging technology, AI and automation specifically, will have to be used to address some of these challenges, right? But the question is, how? These technologies feel daunting in some ways, and there's a lot of hype around it. What's reality and what's real? How can you, in a practical manner, apply this to the problems of your warehouse? And without necessarily having to go through a whole rip and replace of your existing systems. I don't think anybody ever wants to go through another SAP to Oracle or Oracle to SAP transformation unless you absolutely have to, right? So the goal is, how do you augment the existing systems? Fundamentally, the problem we're trying to solve is most WMS systems, most ERP systems are great at what they do, but they are static rules-based systems, right? They're implemented and configured for a specific moment in time. And that's kind of how we made our money, frankly, in the services side of things, right? But the fact of the matter is, your business is not static. It changes all the time, and it's very hard to keep changing your systems to reflect the reality of your business. It's almost impossible to do that on a day-to-day basis. To add to that, I would submit that the entity in the supply chain that probably has to deal with the largest amount of uncertainty is probably the warehouse on a day-to-day basis, right? Shipments are late, people don't show up, carriers are blocking up your door. All these challenges you have to deal with. That's kind of what we are trying to address. Talking about hype versus reality, specifically AI. It's probably at the peak of its hype cycle now, right? To the point where, again, per Gartner, more than 70% of enterprises are planning to implement AI in the next year or two. Problem is, less than 10% of them are really going to get any benefits out of that. Right? And why is that? Because people are just throwing stuff at the wall and seeing what works. Right? The interesting thing is the next statistic, right, which seems to contradict that. It says 65% of all short-term decisions are expected to be automated. How is that possible if only 10% of your Gen AI implementations succeed? Well, the answer is it's not necessarily Gen AI, right? Whenever we talk about AI now, it's all about Gen AI because that's the new cool kid on the block. Right? And it's great at what it does. It feels like magic sometimes, especially in terms of content generation, some of the natural language processing, those sorts of things, right? But good luck getting that to solve some of your supply chain optimization problems. What you need for that is Gen AI's nerdier, more math-focused cousin, and that's the applied AI. That's the mission-critical AI, right? These are specific AI engines that are built to solve specific optimization problems in supply chain. And that's kind of what we're going to be focusing on in this presentation. We'll talk about both and how they complement each other, but the specific case study we have is going to focus more on the applied AI side of things. All right, so how are we attempting to solve this Zebra and Synkrato together, right? What is the autonomous warehouse as opposed to the automated warehouse, right? To us, an autonomous warehouse is not only automated, where some of these tasks are repetitive tasks you use these robotics for, but it's adaptive. It's evolving. It's optimizing continuously, right? It's making decisions for you. And you're truly managing by exceptions. That's the holy grail. Not saying we are there yet, but that's our North Star. That's where we're going to, right? How do we think we're going to get there? 3 pillars that we're building on. One is all the cool technology that the Zebra has, right? The human augmentation tech. And we say human augmentation not as some sort of euphemism. Maybe we are optimistic, right? But we don't think of this as human replacement technologies because in this era, we can't get the people we need to do the jobs we need them to do, right? We think of these technologies as enabling them to do more with less. Second, these technologies includes things like AMR, Zebra Robotics, RTLS systems to monitor your dock doors, connected workers, and forklifts. Computer vision is going to be a huge part of this. But the second crucial piece of this is as systems get more complex, right? How do we manage them? It's already pretty hard for people to orchestrate tasks across all these systems, to look at all these different streams of data and make intelligent decisions on a day-to-day basis. It's going to get worse, especially with the proliferation of machine customers, right? Where these systems are talking to each other and ordering from each other. It feels like a very Skynet type of future. But that's kind of where we're headed, right? How do we manage that? You're going to need some layer of intelligence that can orchestrate all these, that can make a lot of these short-term decisions for you. And that's why we use the AI layer. On top of that, with all these systems, we're going to have to find a way as humans to interact with them better, right? And humans are a very visual species. We understand things much better when we can see them. And that's kind of why we see the importance of a digital twin that you use not only to control and monitor these systems, but also to run simulations, to do what-if scenarios and see, if I add a rack or a conveyor, is it going to really impact my efficiency? And see that effect in the digital twin before you roll that out in the real world. That's kind of where we are building towards. That's a future that Zebra wants to have at their warehouse. At this point, we'll talk about the specific problems.
Yeah, so we have our largest distribution center in Europe, which is in Netherlands. It's north of Amsterdam. So the current limitations that we had in the system is that the warehouse slotting is performed manually. So our WMS systems that we use does not have out-of-the-box warehouse slotting capabilities. And for the folks who are not aware of what warehouse slotting, it's a process of organizing inventory in the warehouse to efficiently help with your order fulfillment. So that's one of the problem that we have. And then the second problem is that our warehouse is 92% full. So the space utilization is a key there, right? We don't want to have the space full for the inbound material. So that's why we want to utilize it. We want to be very efficient with the space. And then the labor also, all the planning happens, the labor planning and everything, space planning happens in spreadsheet manually. So it is more of a reactive versus predictive. So that's the key problem statements that we were trying to solve with this. So you want to talk about the solution?
Sure.
Yeah.
And to make it clear, it's just one of the problems we're trying to solve. Right? We took this as a perfect example because it's one of the lowest hanging fruits. It's the one that gives the biggest bang for the buck. Right? So how do we do this? Very simply, it's a three-step process. Our goal was to take all these cool technologies and make it as simple as and easy to use as possible. Right? So step one, we build a digital twin of the warehouse. And I will show you exactly how we did that. Second, we input in data from your core ERP systems. And again, this is data that you normally all have. It's not extraordinary stuff we're asking for. Third, we set the warehouse configuration parameters. How does your warehouse operate? Because each warehouse is fundamentally different, right, in terms of the layout, in terms of resources, and in terms of how they pick. So we let you configure that. Once we have that, then the AI engine runs and multiple times a day comes up with actions, recommendations that you should do that will make you better today. Not years from the future, but today and tomorrow and day after, right? And it does that every day on an ongoing basis. So let's take a look at that. First step is a digital twin. And the goal of the digital twin was to provide a visualization tool that allows you to run simulations. It's like a Google Maps for the warehouse. And Zebra has robotics already inherent that we're going to integrate with this digital twin so I can monitor them in real time. So short video of how we built it. And again, digital twins, there's a lot of uncertainty of how complex this is. Now, how hard does this have to be? And our answer is it doesn't have to be because a warehouse is not necessarily a very complex structure. So we started off with AutoCAD, Revit, the usual suspects to try and build this. And then we went back to the drawing board and said, if my daughter can build a world in Minecraft, why can't we build a digital twin, right? So we actually used Unity, the gaming platform. And we created a platform on top of that that allows you to very simply create your warehouse. It takes us from start to finish about less than 5 days or so to build a warehouse from scratch, right? And as you can see, it's a pretty simple structure. You set up your zones, you have your locator naming nomenclature to map what you have in your ERP systems. Once you do that, then you can start adding your racks. And again, every warehouse may have, 20, 30 different types of racks. You're not going to have 1,000 different types, right? And once you design a particular rack configuration, the engine can reuse it multiple times. You can say, I have a rack that's 3 bins, and each bin is this particular dimension. Once you have that, once you create your aisles and zones, you can say, this aisle has 10 rows of these racks. The end result, once you're done with this, is something that looks like that, right? And that's an actual warehouse. Forget all the pallets. We put that in to make it look prettier, but that's an actual warehouse, right? The goal with this is a critical input to the AI engine. It provides slot geometry and slot geography So we know exactly how big the locations are and how far they are from each other and from the staging lane, right? So that's step one. Second, let's transition to an actual end-to-end walkthrough of how we solve this problem at Zebra using the digital twin and the AI engine.
Right, so this is the our Heronmean warehouse. This is the real video of the warehouse, and you can see all the equipments in action and Zebra robot.
So that's kind of where it morphs into the digital twin equivalent of the same warehouse, right? So that's step one. Once we had that, we loaded the current inventory in. So now it's not a static twin, right? It can reflect real time your resources and your locations and your inventory. Second step is to pull in data from your ERP and WMS. And I'll show you a slide of exactly what data we're looking for. Third step, configure your warehouse. What pick methodologies do you use, right? Do you do bulk picking here? Do you do cluster picking there? Do you do pick and pass? What are your item restrictions, right? Zebra, all batteries have to be in the odd number location because there's sprinklers up there. Those sorts of things, right? Once we do that, the AI engine comes back with a bunch of different analysis. The first one is the perfect world. If you started off with an empty warehouse from scratch, and you have to optimize your product placement, how do you compare to that? And almost invariably, the answer is pretty poorly, right? Because your business changes all the time. The second is we understand that nobody lives in that perfect world, and we understand every move has a cost. So what can we have you do today that will make you better today, right? And what efficiency can you gain? Apart from that, we do things like SKU analysis, SKU affinities, right? Standard market basket stuff. You know, if you buy milk, do you buy eggs? Sure. But if you buy 2 cans of milk, do you buy 3 cartons of eggs or 4 cartons of eggs? Right. Once you have all that, then you can go back to the digital twin and validate the result. So if you look at a search for a particular item, it'll tell you where it is currently and where we think it should be, because we don't think you're going to be selling that anytime soon, this week or next week. It doesn't matter if it's your top ABC item. What does that mean today and next week, right? That's kind of what we focus on, right? And it's a very helpful and visual tool to kind of help you navigate that. Second, you can do simulations. I have an empty wall at the end of the warehouse. Maybe I'll put a rack there, put 10 shelves there. What is that going to do to my efficiency? Is it going to make me better? Or is it going to justify the cost of adding that rack or a conveyor? That's one type of simulation you can do, changing the physical structure of the warehouse. The second type of simulation you can do is changing your data. For example, you're going to be running a demand a promotion, a buy one, get one free, and you expect a spike in demand for a specific item. You can feed that into the engine and say, how is that going to impact my warehouse? And how can I, as a warehouse manager, start getting ready for that type of spike in demand? Third, you can change how your warehouse operates. You know, maybe I'm doing cluster picking today, but is that really the right strategy for my warehouse? You know, should I switch to more, auto picking or wave picking? Is that going to make me better with the resources I have and the picks that I have, right? So there's a bunch of predictions that are built behind the AI engine, predictions of order workload that we think we're going to be doing today. That feeds into labor forecasting. Predictions of your inbound forecast. Yes, your suppliers are all saying it's going to show up today, but what do we think is most probable that will actually arrive in your warehouse today? Those are the kind of questions that the digital twin and the AI engine can help answer. So how do we measure the results? Right now, we're doing it by data, right? Because every day we get feedbacks from the WMS system as to what you actually did compared to what you would have done without us. And that's kind of how we're measuring it. In phase 2, obviously, since Zebra being Zebra and they have all this cool technology, we're enabling RTLS, and we're enabling the connected worker, putting an RFID chip on every forklift, and we're going to track exactly how much distance each forklift drove, not only to measure increase in productivity, but as a measure of how much better we're getting from a sustainability perspective, right? Are we driving 100 miles less every week, and what does that impact? So to kind of simplify things, this is the exact data that we're getting in from Zebra. So it's, as you can see, nothing very complicated, right? It's your items, your unit of measure conversions, your sales history, your pick history, your receipts, your current inventory, and ASNs. Pretty much any enterprise, any WMS system would have that, right? That is one primary input. The second is from the digital twin. As I said, we get the slot geometry. We use all the pathfinding algorithms to figure out how far these locations are from each other, and the warehouse configuration. The outputs are two primary things. The primary output we send back to the WMS are a series of moves that we recommend you do today. Think of these as replenishment moves, but not driven by min-max that somebody set up like 6 months ago, but dictated by what we think you're going to be doing today and dictated by what material you're going to get. Second is any inbound product. What are you going to do with it? Where should you put it away? Those are the two primary outputs that go back to the WMS. In Zebra's use case, the end user doesn't even realize all this exists. As far as they're concerned, they're still using the WMS. They're still executing tasks like normal. It's just that these tasks are more intelligent. With that, Abhishek, want to talk about where we're going next?
So the current phase one that we have is we are going with the global labeling platform, digital labeling platform. That's a cloud-based Synkrato solution that we are using. And we are also building this digital twins. We have already built it. We are doing integration now, and we are going live next month in May, or this month. Today is 1st May. So digital twins in the Netherlands warehouse, we are going live, and then we are also doing, as part of the digital twins, we are also doing the slotting of the Netherlands warehouse. In phase two, which is later half of this year, we are going to roll out the similar solution for our largest distribution center in the United States, which is in Wisconsin, Kenosha, Wisconsin. So we are doing that. We are also working on labor forecasting, warehouse labor forecasting, and we are going to integrate Zebra robotics into the warehouse. So the digital twins can decide which robot is the closest to the task and direct those robots to do the task. So we also have some AI-driven operations, like Amin mentioned about connected resources, and then we also have a Zebra product called MotionWorks, which we are implementing in the staging area to have with help with the consolidation. So that's RTLS-based staging lanes. And we also are doing task and resource planning for task augmentation, and then 3D pathfinding. And we have a Gen AI chat that we are enabling on Zebra devices, handheld devices, so that people can go and treat it as a co-pilot and learn about the steps, how to do steps. And let's say if they want to receive or do whatever, I'll talk in the next slide maybe. Sure. And then we'll just... That's the preview of the phase two use case, where you can just ask questions about how to do a receipt, what needs to be done, and we have all our work instructions that are going to be shared with the Gen AI tool to be able to answer the questions properly.
In our view, Gen AI we're using as a human interface layer, right? The hard work is being done by the applied AI engine. Gen AI, we're using it for three primary purposes. One, to be like a logistics co-pilot to ask questions and get them answered, right? It's because it's been one of our pet peeves that we have taken warehouse managers and tried to turn them into system analysts. The amount of time that they spend in front of a computer trying to get basic questions answered, right? It's also your personal report writer. It's pretty cool at doing all that sort of stuff. And it's also very good at converting unstructured data, dark data, right? Taking photos of a pallet and asking, what is this thing? Well, that thing is actually a pallet that was picked by John Smith and is waiting for a carrier at 2 o'clock to come pick that up. Those kind of inferences that Gen AI is extremely good at. The key, though, we have found is that it is not a plug-and-play system, right? No matter what anybody tells you, the only way we can make this relevant and useful is by training it not just on logistics, right? But when training on specific systems. So we have spent the last few months training it on the Oracle WMS system to say, this is how your data looks like. And when you ask a question, this is what the output should be. Otherwise, it's just superficial, right? To be really relevant to what you're doing to your data and for it to be secure, you have to train it on specific systems and sources. All right, that leaves us 5 minutes for questions. I think they did pretty well in terms of listening.
Yeah. Yes. Yes, yeah, go ahead.
So you mentioned that you're starting out, you're building this off of
Yep.
Oracle's WMS system. I would assume that it's going to be integrated with a pretty wide range. So will it integrate? Are you planning on rolling it out, integrating with? I assume if you're working with Oracle's WMS, it could integrate with NetSuite, for instance, as an ERP and things of that nature. The more data it's able to pull, the more it's able to actually intelligently come up with these solutions. Is that accurate?
Yes, we are system agnostic. Now, we are already working with another customer on an SAP instance. We don't really care, right? The data that we are looking for is pretty standard across all these systems, right? So doesn't matter if it's NetSuite, Oracle, or SAP. The goal is that this will work equally well on top of all those.
Okay, and just a follow-up question, as far as like a timeline is concerned, do you know when a rollout would be for actually being able to start seeing some of those practical steps to be able to integrate with those and then roll it out to the general public?
It's already available, right? So
okay.
We've already started working with other customers, right? So in terms of a timeline, what a typical timeline looks like, like I said, it takes us less than a week to build a digital twin, right? It takes us about 30 days to get the AI engine, fine-tuned based on your initial input data that you give us. And you can give us Excel files, right? That's what we will use. So in 30 days, you're ready to see results, right? You can start exporting those results and acting on them, right? The unknown part really is the integration. Do we already integrate with this? And we don't, it's not like we charge for integration. We see it as making our systems better. But there's still a time component, right? Now, depending on your system, we have to build those pipelines, right? And that could take 30 to 60 days, right? But within the first 30 days, you should be able to start seeing and validating the results in your system.
Okay, great. Thank you.
So I'm not very knowledgeable about warehouse management, so but just question to understand. So what's the purpose of the visual representation of the digital twin? Are you using that to kind of physically build the background logic, or the users are actually using that to do something?
Good question. A few different things. One, as a human-in-the-loop validation, right? Once we get results out, it's far easier to see that in the digital twin and see, does it make sense, right? We're asking you to move it from here to there. It's so much easier to see, does it make sense to me in my business, right? So validation. Second, to run these simulations, to say, if I change my physical structure, and then you rerun the AI engine, it doesn't make an impact. If I add a conveyor here, is it worth the cost that I'm going to invest in that? Third, as you integrate more automation, more robotics, right? It's a visual monitoring tool of, where are all your robots in the warehouse right now, and how do you orchestrate them, right? Augmented reality, we are capable of it, right? The problem is, it's literally a pain in the head to ask people to wear a glass and work for 8 hours using the glasses, right? So while it's certainly capable, the hardware, in our opinion, is not there yet. So we're using it more for training purposes than anything else. Did that answer your question?
Yes.
All right.
Hi, good morning.
Good morning.
Quick question on slotting. Would this work even in warehouses that use dynamic slotting rather than fixed slotting?
Absolutely. So two kinds of things, right? One, dynamic slotting, most WMS systems look at if you release a wave of orders, for example, right? It looks at, okay, this is the wave of orders that I need to fulfill, and then how much do I actually need to replenish to fulfill that demand, right? And it's a two-step process. You do the replenishment, then you do the pick. Problem is, it's very reactive, right? And it's often at times too late, because now you're doing this, and now your pickers are waiting for it, right? The reason we chose AI is for two reasons. One, we wanted to be more of a predictive type of system, right? Kind of anticipate what you're going to be doing next and doing the slotting overnight or when you have time so the pickers are not slowed. And two, there's a bunch of slotting companies out there, right, that are great at doing what they're doing. The challenge is, and there's a bunch of smart people that have spent a whole bunch of time building all these complex mathematical models for slotting. The challenge, and a lot of my customers have used that, the challenge is it almost inevitably devolves into a consulting engagement, right? Because I call it the snowflake problem, right? Every warehouse looks superficially the same, but it's slightly different in how it operates, right? And that's where we felt that the AI approach was much better, because it could learn from how your warehouse operates and adapt to it without having to go in and change your entire model to accommodate that.
And then, sorry, follow-up question. I assume that it would also be able to suggest or run simulations on, how many zones in a warehouse do I need, and what is the most efficient split of, the floor into zones. Would I be able to simulate that?
It can simulate different kind of pick methodology. The problem that I think you're asking about that we don't do yet is to suggest how your warehouse should be configured. Right now, we are taking your warehouse assets and saying, what's the best you can do with that, right? What I think you're asking is, how do I plan my warehouse? Now, this is my demand.
Well, but maybe an intermediate step. So if I change my zones from this to that.
Oh, for sure. That you can do. Right, absolutely.
Okay.
That is the what-if scenarios, right? So even in Zebra, we have a warehouse which has, I think, few aisles that are sprinkler-enabled, and we can store batteries in there. So we can run what-if analysis to show if we were to add one more aisle with sprinklers, does it make sense? Does it make the operations better without disrupting the operations? And so we can do that all what-if analysis.
Thank you.
Thank you. I think we are out of time.
We'll be in booth 44 if you have other questions. I think we are out of time, but thank you all so much.
Thank you, everyone.
Okay.